monitoring and comparing data on the info display. Now you can deactivate
the Rosviet module, about a 90-second process, and that will be the precursor to the actual physical separation of the Soyuz from the Rosviet module, with springs on both sides of the docking interface pushing off against one another to enable the Soyuz to fly free of the International Space Station. The undocking is scheduled at 2:37 and 30 seconds a.m. Central Time, 3:37 and 30 seconds a.m. Eastern Time, with, again, that physical separation followed 3 minutes later by an 8-second automated separation burn of the Soyuz engines to increase an opening rate away from the station to a safe distance away from the vehicle for the deorbit burn that will take place at 5:06 a.m. Central Time, 6:06 a.m. Eastern Time. Again, this live view now once again of the Soyuz MS-12 as it moves just off the southeastern coast of Africa, soon to cross the coast of Madagascar, moving from southwest to northeast as countdown clocks here tick backward toward the undocking of the Soyuz from the International Space Station. Once again, the undocking that is scheduled about 27 minutes from now will be initiated with the separation of the Soyuz vehicle from the Rosviet module. In this animation, you see the undocking process take place. The Soyuz again will move to a safe distance away from the International Space Station for the deorbit burn that will be initiated at 5:06 a.m. Central Time. This is a 4-minute, 42-second retrograde firing, a braking maneuver to slow the Soyuz down by 128 meters per second, allowing it to drop out of orbit for its high-speed entry back into the Earth's atmosphere. The pyrotechnic separation of the three sections of the Soyuz will take place at 5:34 a.m. Central Time, 6:34 a.m. Eastern Time. All that's left at that point is the descent module with the 3 crew members on board, with the heat shield repelling the high temperatures that will build up around the spacecraft in the plasma regime. The command to open up parachutes will be initiated at 5:45 a.m. Central Time, 6:45 a.m. Eastern Time. First a drogue chute, then 2 pilot parachutes, and then the main chute that will significantly slow down the descent rate of the Soyuz vehicle. Just a few seconds before touchdown, soft landing engines will fire in a final braking maneuver. Touchdown again scheduled at 5:59 and 45 seconds a.m. Central Time, 6:59 a.m. and 45 seconds Eastern Time, just a few seconds before 5 p.m. at the landing site in Kazakhstan, which will be 1 hour and 58 minutes before sunset. The Russian search and recovery forces and a NASA team embedded with that search and recovery team is airborne in a Russian Antonov 26 aircraft from the staging city of Karagan to Kazakhstan, down to an airfield in Zhezkazgan, which is about 90 miles to the northwest of the landing site itself. Once the Antonov arrives in Zhezkazgan, the landing team members will be deployed to a variety of almost a dozen Mi-8 helicopters that will be airborne around the time of the deorbit burn for the landing site itself. They will arrive at the landing site in a racetrack pattern around the area of the final trajectory of the descent of the Soyuz spacecraft, and after touchdown they will land in sequential fashion one by one to begin the process of arriving at the capsule itself and begin the work to extract the crew, get them into chairs so that they can have a few minutes to regain their equilibrium and to enable which is about 90 Airport in Baikonur at the launch site. They would be dispatched to the ballistic landing site in the unlikely event of a malfunction on the Soyuz at the launch site. Result in they would be dispatched to the ballistic landing site in the unlikely event of a malfunction in Baikonur at the launch site. Result in they would be dispatched to the ballistic airport in Baikonur. Landing site, after which they will land one by one. The first series of helicopters will be with the RSC Energia technical personnel who will see to the safing of the spacecraft and the initial extraction of the crew. Other support helicopter personnel, including NASA personnel, will be arriving within minutes thereafter. Also at the landing site to welcome home the crew and recover some of the cargo samples that are being returned. Also at the landing site to welcome home the crew and recover some of the cargo samples that are being returned. Also at the landing site to welcome home the crew and recover some of the cargo samples that are being returned. Also at the landing site. There are some of the helicopters that are at the Zhezkazgan airport. There are two other Soyuz vehicles that are docked to the International Space Station landing site to provide 10 lifeboat support, if you will, for the other dispatched to the prime landing site behind as part of the Expedition 61 crew in sequential fashion, one by one, and arrive at the landing site in a racetrack pattern, just about 16.5 minutes from now, under the command of European Space Agency astronaut one by one. The first series of helicopters command of the station in the change of command ceremony on Wednesday morning. RSC Energia Expedition 60 Commander Alexei Olshinin. The Soyuz MS-13 spacecraft is currently docked to the Poisk module on the space-facing side of the Russian segment of the International Space Station. The Soyuz MS-15 spacecraft, which was launched last week from Baikonur with Russian cosmonaut Alex Gripochka, Al Mansouri, and NASA astronaut Jessica Meir. That is docked to the aft port of the Zvezda service module. Just to run down the key times that lie ahead here in the timeline that will lead to the landing of the Expedition 60 crew. And just to run down the key times that lie ahead here in the timeline that will lead to the landing the Expedition 60 crew. Just to run down the key times on the Earth-facing side of the Russian segment of the station. That command to be issued just 13 minutes from now. 90 seconds later at 2:37 and 30 seconds a.m. Central Time, we'll have physical separation. Springs on both sides of the docking interface will push off against one another, enabling the Soyuz MS-12 spacecraft to fly free from the International Space Station. 3 minutes later at 2:40 and 30 seconds a.m. Central Time, an 8-second automated burn of the Soyuz engines will be initiated to increase an opening rate for the Soyuz away from the space station, ultimately to arrive at a point about 62 miles away from the station for the deorbit burn that will take place at 5:06 and 19 seconds a.m. Central Time, 7 and 3 seconds a.m. Central Time. Entry interface will take place at an altitude of 326,444 feet above the Earth, or 61.9 miles. At that point, Haig, Ovchinin, and Al-Mansouri will feel the first tug of Earth's gravity against their bodies. For Haig and Ovchinin, their first sensation of gravity in 203 days, and 8 days for Al-Mansouri. Within a minute and a half after that, they will enter into the plasma regime, where basically a fireball will build up around the Soyuz spacecraft. That heat, building up to 2,500 degrees Fahrenheit, will be ablated by the Soyuz heat shield. Entry into the plasma regime is scheduled at 5:38 and 34 seconds a.m. Central Time, and will last for about 4.5 minutes. Following their exit from that plasma regime as they go lower and lower into the Earth's atmosphere, the command to open up the parachutes at 6.6 miles above the landing site will be initiated at 5:45 and 24 seconds a.m. Central Time. And from that point on, we'll be poised to see the vehicle under the chutes if we're lucky, and landing scheduled again at 5:59 and 45 seconds a.m. Central Time, which will be 4:59 and 45 seconds p.m. Kazakhstan time at the landing site.
Do you see the video? Not yet. At 10:30:00, we are ready to send E2 command. Copy. And please confirm. At 10:30:00, we are ready to send E2 command. Copy. Your control panel. And please confirm. At 10:30.